How are you feeling today? Good? Okay, so our exam 1 is exactly 2 weeks from today. I posted the review sheet on Blackboard. It will be on chapter 1 to chapter 8, except chapter 5. And most likely we'll go to finish chapter 7 today, this is chapter 7. And we may start chapter 8. If not, we still have 3 more days to work on chapter 8. And a reminder that next Monday there is no school and Tuesday is a Monday schedule. However, we're not going to have any class on Tuesdays. Okay? That means this is our last in-person class before exam. Oh, we have 2 more classes, because I can see one of them. So we have class this Wednesday, next Wednesday, and then your exam will be next month. Okay? Any questions? Comments? Chapter 8 is a short chapter. So we have two more days, probably we're going to finish everything, and then we may have a little time to do it.
Yes, the last
yeah, next week Wednesday, most likely. Okay, any other question? No? So chapter 7, we have 3 things: discrete random variable, binomial random variable, and uniform variable. Uniform distribution. So in the uniform distribution, last week I showed you a video what is uniform distribution and why do we care. Well, mostly we care because uniform distribution has a very nice way of finding probability. We have a table of probabilities which we call Z table. If we can convert any distribution into normal distribution, then we can use that probability table and we can get the probability easily. That's what we care about, Z table or the normal distribution. So the Z table is based on only standard normal distribution. So that's why whenever we have anything of normal distribution, it means if we can have mean anything, standard deviation anything, but our goal is to convert that into mean 0, standard deviation 1. That transformation is called Z-score transformation, to convert any uniform distribution into standard normal distribution. And the Z table is actually the area under the bell curve. So whatever we have, let's say when we have our mean 0, so we have this, when we have, let's say, our Z is negative 1.5. So whatever we have, the area on the left side is given in the Z table, which is the probability. So using the Z table of standard normal curve, to find the area is whatever area we have. So Z table is something like this, where we have a number below Z and a number across Z. So we convert any information into normal, standard normal distribution, and we get the score for Z. Let's see how we read it. We take a number from the below first, and then a number from the right side, the left side. So let's say we found our Z is negative 4.5. It means say negative 0.45. So we go to negative 0.4 on the left, and then we go 5 here at the top. So whatever number we have, that is the Z value for, there is a probability for the Z value negative 0.45. Or let's say we have something like 0.5. Negative 0.5 is here, and 0 is here, so negative 5.0 is this number. Let's say we want to find what is this probability for Z negative 0.37. It doesn't have any 7, but the actual table, it has 6, 7, 8, 9. It has many things on the side, many things on the bottom. So what we do is we go to Z table, and whatever we are looking before, we take a number from the downside and take a number on the left side, we combine them, wherever they intersect, that's the probability you're looking for. So the area under the curve is that Z, which is a probability. We already said that. Since all the areas under the curve are the left side of the Z, that means if you want to find the right area directly is not given the table. So what we do, we take the left area and subtract from 1. Because we have what's the maximum probability we have? 1. That means the area under the curve, the whole area, they sum up to 1. So if you want to find right, all you have to do is subtract the left from 1, whatever remains, that's all right area. And for right, you have to do that because the table is based on the left side of the curve, not the right side. And if you want to find middle of two things, then all you have to do is take the bigger number and separate the smaller one. The middle is that. Okay, let's do some example quickly. But we do need the z table. So it says, what is the probability that C is smaller than negative 0.48? One good thing about the z table is whether you have the equal sign or not, it doesn't matter. We understand. So the equal sign doesn't matter. You may write C is less than or equal, or if you want to see less than. So basically it's asking how much is the area you have on the left of negative 0.48. So negative 0.48 is somewhere here. We are looking for what is this area. This area is the problem. So what do? We go to the z table. And let's see where do I have z table. Anywhere? Here. Z table has two sides. One is for the positive numbers, one is for the negative numbers. So the first page is always negative number, and then the second page, is for the positive numbers. Now, in our case, we are looking for negative 0.48. So negative 0.4, it's not here. You have to scroll down. Negative 0.4 is here. And you're looking for 8 on the upside. So let's see where is 8. Which one? The second left here. So the whole thing is 0.4. And this whole thing, oops, I can't do that. That whole column is 0.8. So where do they intersect is this one. Point what? 3156.1. So 0.3156.1. This is the probability. That is how much area we have under the curve on the left side of that number. Any question? In the exam, I'm going to give you the z. Any question? And the z table is also available on Google. Just write z table, and then you'll see so many z tables there. The next one says find the probability that z is less than or equal to 1.31. So we go to 1.31. See, 1.31 is a positive number. That means we need to go to the negative side. So this is the negative side. We need to go to the positive side. I forgot what you're looking for. 31. So where do you see 1.1? Which number? 1.1, yep. So 1.3 is on the left, and the last digit is 1. When you combine them, it's 490. 1.3 on the left, and on the top, 0.1, yeah. Combining them, wherever they intersect, that's the probability. 490. 0.90, 490. And remember, the area will always be positive. So if somehow, for some reason, you get a negative area, that means something is wrong with the calculation. Oh, and then how do you write it? How do you draw it? 1.31 is somewhere here. So we are finding all the area that is smaller than C is 1.31. How about the next one? We want to find the probability that our Z is negative 1.45. Somewhere here, negative 1.45. So you're looking for the area on the right side of that. Now what do you do? Mm-hmm. 1 minus the less than. Why do we care? Because this is what we have in the chart. So let's see how much we have. 1.45 negative. Since this is in the negative side, so we have to go to the first page. 1.45. So, what's wrong with this? 1.45. No, I need to scroll more down. Now, can you see negative 1.45? Can you see it in the chart? So we have negative 1.4 here. We keep going until we reach 5. So what number is it? 0.7. So 1.4. Oh no, sorry, not this one. 5 here. We have 5 on the top, 4 on the left. Combining them, negative 1.45. 0.7353. 7353. 7353. And then, yep, we have to do math. So let me guess. 10 minus 3 is 7, 9 minus 5 is 4, 9 minus 3 is 6, 9 minus 7 is 2, 9. Is it? Point 92. And it makes sense. It says we have 92%, about 90%. And look at the area. It is definitely 150%, it's close to 90%. Right, the total area if you consider. Any question? No. So, yes, sir.
So we're only always minusing one whenever it's to the right.
Mhm.
It's not really relative to where.
Right. It doesn't matter why you're on the negative side or positive side. The main thing is, are you looking for the area right or on the left?
So even if it was positive 0.4 480. So we're doing it by still.
1 minus the. And now we have something that's between them. So between them is easy. We don't have to subtract from 1. All you're going to do is you're going to take the bigger one. This is the bigger number, right? 2.1. So we are going to take probability z is less than 2.11. And we are going to subtract probability z is less than negative 1.03. So how much is the area for the bigger number? Subtract how much is the area for the smaller number. So 2.11. We go to positive 2.11. How come the mouse doesn't work? Can? Okay. Positive 2.11. How much is 2.11? 2.10, 2.11. Please write the second one.
Yeah.
98.25.7. All right. 2.1, because we have 1 here and 2.1 here. 98.25.7. 98.25.7. 98.25.7. And now you're looking for what's the probability? Negative 1.03. So we are going back on negative side. How much is that? 1.03. Now I have to reduce. Probably negative 1.03. Here, 1 here, 15.51. Yeah. So 1.0 is on the left side here, and 0.3 on the top. They both intersect at this point. Point 15.1. So 0.15.1, and then whatever we have, that's the area. So we have 2.11 here and negative 1.03 here. The area is in the middle. So how much we have? Did you guys calculate? 0.8316. Now an interesting one. What is the probability that Z is lying between -5 to +5? That means we need to go to the Z table and see what score we have for -5 and +5. But if you go to Z table, look at the table. It doesn't have anything after 3.99. After 3.99 on the negative side, it doesn't have any number. It doesn't have -4. It doesn't have -5. Also, if you observe on the positive side, We don't have anything that is bigger than 3.99. We don't have 4, we don't have 5. 1. Perfect. Because look at the chart. The smallest number is negative 3.99. And the largest number here is positive 3.99. But we are looking for negative 5 to positive 5 somewhere. So the total area, well, we don't care about this. We only care about, I meant highlight. We care about this. We know this total area is add up to 1. That means it doesn't matter what zero we have on the left and on the right. They all are add up to 1. Okay. Any question? So that's how you're going to find the probability using the table. And now I'm going to show you when do we use the z-table? When do we use this type of probability? Can I change my slide? Okay. So in order to convert any type of normal distribution into standard normal distribution, this is the formula we are going to use. This formula is that, well, to find the z-square, all you have to do is take the x value given to you, subtract the population mean, divide that by the population standard deviation. So that means we are going to have all 3 columns given to us. All you have to do is make the calculation, or do the calculation, and figure out what z we have. Okay, for example, the average salary for the first year teacher is 27,099. The average salary for the first year student. What does average mean? Mean. No. So average mean they are giving us mean. The question is, what is this mean for? For the population or for the sample? It says the average salary for the first year teacher. So first year teacher, is it a sample or it's a population? If it's a sample, they're going to tell you what's the sample size. Did they tell you what's the sample size? That means first year teacher. What does it represent? Sample or population? Population. Think about all first year teacher throughout the universe or throughout years. Okay? So if you consider all first year teacher throughout years, that means we have a big size. Anytime you are working with a big size, it represents population. So that average mean is actually mu. So they're telling us our mu is this. With a standard deviation of that. So we know this is sigma. If that is mu, that has to be sigma. Now, what's the probability that a randomly selected first year teacher has a salary for all 3 or 4 options? The first option says, what's the probability that the person here we picked, he has a salary less than $20,000 per year? That $20,000 represent x. X means the value for the sample. not sample, the value for a random person. So we know the formula says convert this into standard normal distribution by applying this formula. We are looking for a person, we are looking at a person who has, we want to know what's the probability that he has less than $20,000 per year when the normal average people for all first year teacher, they have 70,989 with a standard deviation of 3250. Go ahead to the calculation. Negative 2.458. Unfortunately, the Z table has only 2 places after the decimal. So if you round, what number are you gonna get? 6. That's the Z. Now we want to know what's the probability that our Z is less than that number. So probability that X is less than 20,000 is same as probability Z is less than negative 2.48. These two things, they are the same thing. We know how to find the bottom one because we have a table for that. So we go to our table and criteria for negative 2.48. Negative 2. Okay. Gonna edit. Negative 2.4 is here. And what do we have for 8? Negative 2.401234 here. Double 0. 657. Zero point 0.00657. So it doesn't make that much sense, right? 48. It's 46. Sorry, my bad. I got the wrong number. Thank you for catching that. 46 means we have to go 2.46 here. Oh, they are very close. One is 695, one is 657. Okay, 695. 00695. What does it mean? It means we have only 0.695%. In other words, 0.7% chance that the first year teacher will have less than $20,000 income. It means it happens rarely. It's not true. It has a very small probability. That is definitely the salary for first year teacher is more than 20,000, right? And then the next one. What's the probability that they have a salary between 20 to 30,000? What do you think? What do you do? Go ahead. 20,000. So fortunately, we only have this before 20,000 here, right? On the left. Perfect. So we have to do the math twice, but you don't have to do it here because you already did the first part on the left page. So let's say whatever we get from here is Z1, and whatever we get from here will be Z2. So Z2 is, Z1 we already know. What's wrong? Is 0.00695, and to find C2, we do 30,000 minus 27,989. Oh, so not Z, it's probably just Z1. Divided by 3250. 30,000 minus 0.62 after rounding. Good. That means now we need to know what is the probability that Z2 is less than 0.62. 0.62 is a positive number. So you go to the Z table on the second page. Zero point 0.62. What do you see? Go ahead. 0.73237. Yep. So 0.6 on the left, 2 is on the top. Both of them, they combined at 73.27. 73.27. 73.23.7. So probability that X is between 20,000 and 30,000 is 0.7327 minus 0.00695. Here is 1,000, okay? Well, let me try. 7 minus 2 is 7 minus 5 is 2. 13 minus 9 is 6. Sorry, 4. 11 minus 6 is 5. 2, 7. Is correct? Question. Ask me how. Did you probability? Yeah, compare it to percentage. Yeah, because I know the decimal two places. How? It's on the Z table. Go to Z negative 2.46. Is the probability, but it doesn't make sense. So if you convert it to percentage, you'll see it's very less probability. So this is our answer. So if it doesn't make sense, we see that we have 72.5% probability that their salary will be between 20 to 30,000 per year. That is the good number. 72 is a high. So it does that makes more than 50% chance. Now, what's the probability that they will earn more than 34,000? So the average for all the past year is 27,000, down to 28,000. Now, average is 28,000. What's the probability that they are going to earn more than 34,000? So, how do you find more? We need to subtract them from 1. But first, we need to find the Z. So, probability, not probability. First, we need to find Z. Our Z is X minus mu over sigma. So 34,000 minus the average 27,989. divided by 3250. What's the Z for 34,000? 1.35. 85? 3 and 8. They're only half of 1 and 1. Okay. So we are looking for what's the probability that he's gonna earn more than 34,000 is same as 1 minus what's the probability that Z will be less than 1.85. Or if you're confused, never mind. I'll do 1 minus later. First, let me show you with the 1. So this is same as probability Z is more than 1.85. Unfortunately, we don't know how to find how much is the area for that from the table. So we need to subtract the smaller area. Probabilities is less than 1.85. This table has less area, but it doesn't have more area. So 1 minus 1.85. We go to the Z table and you find 1.8 on the bottom, 5 on the top. 1.8 on the side, 5 on the top. So what number we have? 1.8, 8. Number you see? 96, 78, 4. 1.8. I forgot. 1.8 what? 5. 1.85. This is negative. So 1.8 and 5. They both intersect at 96, 78, 4. 96, 78, 4. 96, 78, 4. So how much we have? Zero point zero three 216. If this doesn't make sense, it means only 3.2% chance. Not many people have more than $34,000. In other words, we just figured out that usually the income for the first year teacher is between 20,000 to definitely less than 34,000. So between 20 to 30, most of the people have their salary around 72%, 73% people, which is bad, right? What can you do in NYC with only $30,000 income per year, not even per month? Wow. Yeah, it's a bad starting job. Now we are doing reverse direction. Is this given? Figure out what would be the salary for taxi. So what do you think? What do we do? We are given the Z. And we know C is X minus mu over sigma. They told us our Z is 0.34. We are looking for what is that X. Do we know what is mu? How much is the mu? 27,989. Do we know what is sigma? How much is the sigma? Can we able to solve for X from here? Go ahead, it's algebra. No more steps, algebra. So what do we do first? Did you guys ever notice that when you solve something, you are actually going reverse of PEMDAS? So PEMDAS. It says the last thing you have to do is subtraction. We're not going to do that. Addition, we're not going to do that. Between multiplication and division, never mind. It's getting confusing. So the first thing we do is we want to get rid of the denominator. So we multiply both sides by 3250, so they cancel out. We get x minus 27,989 equals 3250 times 0.34. Next thing we do is we add these amounts to cancel them. So 27,989. That gives us how much money we need. $29,094. $29,000. What's the $100,000? Okay, so my plan is to give one of these diagram from chapter 7. So actually from chapter 7, I want to give 3. One is from the binomial, one is from the discrete, and one is the uniform. These example, the overall example, A, B, C, D. That whole thing will be too much. Probably one of them. I got A, B, C, or D. Because our exam is only 1 hour 15 minutes. And actually the department said, make the exam for 1 hour and then have 15 minutes lecture. The department said, have the exam for 1 hour and then the 15 minutes the lecture. In our case, not sure yet. But so far my plan is to give let's see. Actually, we are done in chapter 7. That's all from chapter 7. So let me go to the review sheet and tell you what my plan is. My plan is to give one from here. What happened? So my plan is to give one from here. Something is definitely wrong with my screen today. It's very sensitive. See, I can't even touch. And then find mean, median, mode, range, combining them, 1. And in that one, I also want to put variance and standard deviation. So combining all of these is one. Then definitely 5-number summary. Draw the box and whisker plot. But whatever I'm going to give here, you're going to arrange that using stem and leaf plots. Then chapter 6. Chapter 6 is the most tricky one. There are so many types of questions. I'm not sure which one to give, but most likely 2 from here. In the last final, they had 5 from here. From on the probability, only from the probability. The probability is a very wide topic, and it's hard to decide which one to pick. So probably 2 from probabilities. For chapter 7, 1 from discrete means something like question 1. 1 from binomial, something like question 2 or 3. Actually, most likely question something like question 3. It's easier to do. And definitely something from here. Oh, and this will be short response, like for 1 point question. Find the probability for Z and draw the area. Easy short question. So that is my plan. And now we are going to chapter 8. From chapter 8, 1, at least 1. So far I have 1, 2, 3, 4, 5, 6, 7, 8. So 8 big question, and then so many true, false, fill in the blank, yes, no question. Those each are 1 point. Now for chapter 8, I wanted to do something fun, but I think time will not permit us to have fun. Any question before we start chapter 8? Anything from chapter 6, 7, or the previous chapters? So if we can finish chapter 8 next Wednesday, this Wednesday, that means we're going to have a review next Wednesday, Monday and us. Okay, the story behind chapter 8 is this. We have, let's say, lots of people. Okay? And if you find the average for something from that population, that number will be same as if you pick many small sample size and take their average. That's the story behind. For example, what I wanted to in this class was I wanted to work with your height. So tell me height for all of you, and then I wanted to find the average of that, and then plot it on the number line, and then take 85 people. What is the average height for 85 students here? So it could be this 5, that 5, this 5, it doesn't matter how many samples we have, but we can have many samples of size 5. And then I wanted to take the average for that sample of 5. And if you plot all those samples on the number line, you will see that the average for all the samples, they actually become a normal distribution. Okay? It's a cool thing, like you have many teams, and when you put them together, the same information, put them together, they tend to become a normal distribution. And the average for all those samples we took, it had the same average as the average of the population. It's kind of cool, right? If I take a sample of many sample of same size and take the average, one for individual sample, size of 5, and if you compare the average for all those averages, that is same as I'm taking the average for the entire population. Did you guys understand what I'm trying to say? Okay, so this is the study, okay? Now, some definition, statistic. Any quantity computed from sample, we already know that. Sampling variability. The observed value of the statistic depends on the particular sample selected from the population. Typically, it varies from sample to sample. This variability is called sampling variability. For example, I did not, I totally forgot. Let me post it now. What did I? I remember converting it, but I don't remember posting it. So the review sheet is here. And I'm posting lecture 8 now. Okay. It's there now. Okay, so sampling variability. Okay, let's say the average height for this class is, no, let's say the height for all Statistic 213 students is what? 5 foot? Make sense? What do you think? 5 foot? 5'1"? 5'4"? Okay, let's say the average is 5'4". But if I compare this class, what would be the average for the average height for this class? 5. We have some short people like some taller people like tall people. So if you compare them, I'll say probably 5.1. So you see, the average for the population is kind of different than the average of the sample. Same thing if you go to another statistic party, then probably the average will be 5.2. Maybe some of them will have 5.6. Who knows? So we have the sample gives us a different result of population. So the variability from one sample to another sample is called sampling variability. A population characteristic is what you get from a population, and statistic is what you get from a sample. So we already know that X bar means sample mean, mu means sample population mean, S means sample standard deviation, sigma means population standard deviation. But in chapter 8, we are going to learn a new variable. It will be different. But why can we get this? Well, let's say 10,000 people, they have hired 5 4. Oh, wow. Like you said, 5 4. 10,000 people, they have a mean hired average height 5 4. And now that 10,000 people, we want to take a sample of 10 people. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's have to take many samples of 10 people. Now the 10 people I took from 10,000 people, let's say one of them has average 5'3", Another group has 5.7, another group has 5.4. So if you keep taking 10 people from 10,000 people and keep calculating the average of their height, we are going to get many, many different numbers. If you put all blah, 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 so we are sampling variability. The thing is this. Every average we take, if we plot them on a plane and then make a histogram out of it, the shape of the histogram will be a bell curve. It means we have a normal distribution. Now, that distribution we did by taking the average of all the samples, it's called sampling distribution because we are working with samples. We took the average of many, many, many samples. So right now its name is sampling distribution. Now, sampling distribution involves taking a single sample from a population and we interpret the results using anything like histogram or other form. Now, in that sampling distribution, our goal is to see what is the sample mean. Sorry. In the sampling distribution that is based on the sample mean, we have to learn more about the whole process or whole information. Like what do we get from the average of the sample mean? So sampling distribution of the sample mean. To find the sampling distribution of the sample mean, first we take a population parameter like the population mean and take random size of whatever random sample of whatever size you want. Calculate the mean for each sample you are taking and then plot them. This is the process. We keep reading the process as many times as you want. You can do the process like 100 times, 10,000 times, million times. The more you do, the better results you're going to get. Why do you have so many information? It's an interesting thing is that if we have enough data, then the sampling distribution will be normally distributed. And now the new notation is mu with the x bar. So all this time we said mu is the population mean, but now the new notation, mu of the x bar is the mean value of the sampling distribution. Okay, so mean of x bar is the mean of the sampling distribution. Means what mean we got from so many averages of the samples. So the mean of that sample means. Are you listening to me? Remember I said we took so many sample means. Now from all those sample means, we are taking the mean one last time. That one last time is this one. Mean of the sample mean. You know, wonder, well, we are working with sample, but mu is supposed to mean population. So why we are using a population parameter with something to do with sample? One of the reason is this. The other reason is the last mean we took from all those means is actually the population. They are the same thing. That's why. So even though we have x bar, but this x bar is for many samples. This is the final x bar, and the mean of the final x bar is actually the population. They are the same thing. So the mean of the sampling distribution is same as the mean of the population. So we did so hard, but so that's how we can actually figure out what the population means. Usually we don't know population mean. Population is a big size. We have no idea how to find its mean. So what we do, we take many samples, find the average, and then find the average of the average. The average of the average gives us the full population. The mean of the sampling distribution is same as the mean of the population. So they're the same thing for me. But for standard deviation, then that's it. The standard deviation of the sampling mean is the population standard deviation divided by the square root of your sample size. How did it come up with that thing? I have no idea. Sampling distribution has a standard deviation as the population standard deviation divided by square root of your sample size. So in our experiment, we use 10 sample size, it should be square root of 10. I intended to use 5 sample size, so for me, I will write square root of 5. So whatever sample size you have, you divide the population standard deviation by that square root of the number. When the population standard deviation is normal, the sampling distribution of the sample mean is also normal for any sample size. For population, standard deviation, the sigma is standard deviation of population. So we know what's the population standard deviation. Somehow we are going to know, I don't know how, but in our example, they will tell us the population standard deviation. And you are working with this is the sample size. Now find what is the standard deviation for your sampling distribution. And 3 says, well, if the population you are working with is normal distribution, the sampling mean automatically will have some normal distribution. It doesn't matter what is your sample size. They're going to have the same they're going to have the same normal distribution. Now the last thing says central limit theorem. It is the name central limit theorem. It says that, well, the distribution of sample means approximate normal distribution as the sample size gets larger. So if you're working with a large sample size, then the distribution of the sample mean will be normal. It doesn't matter whether the population has a normal distribution or not. Part 3 says, if the population has normal distribution, it means your sampling distribution will have a normal distribution. Then we have more advanced theorem. It says, well, as long as you have a big sample size, we don't care about the population. The population can have normal distribution, may not have normal distribution, doesn't matter. The sampling distribution will have normal distribution if we have a big sample size. Now, how big is the big? Well, some people say 30 is enough, but in real life, it's not true. 30 is not enough. Usually, if you have like around 100, 200, 500, then it's definitely it's a normal distribution. But we'd like to start thinking from 30. Like 30 is a good number, anything more bigger than 30 is fine. But it's not always true, okay? It says often, not always, often. So, what do you want? X bar is sample mean, mean is population mean. If you put them together, it's the mean of the sampling distribution. It means the mean of all possible means. F is sample standard deviation, sigma is population standard deviation. If you put them together, it's the standard deviation of the sampling distribution. Sampling is the standard deviation of all the samples we took. That's the sampling distribution. Any questions on that? When I learned it for the first time, I actually had no idea what is like that. So I had a hard time describing it. But the more I searched about it, the more fascinating it became to me. Like, oh, we don't know the population information, but we can get them from sample. Keep working with your sample as many times as possible. And then if you just take the average of all those averages, that is the population we are looking for. Okay, population distribution is created by measuring every single individual in the population. So for the sample, we take every individual sample from every individual from the sample, and population distribution has a mean, similarly. on a random X. When a random variable X follows a normal distribution with mean, mu, standard deviation, sigma, this can be represented by the standardization Z formula. In other words, in chapter 7, we said in order to convert any type of normal distribution to standard normal distribution, this is the formula we need to use. X will be given, mu and sigma is for the population. Now, for the sampling distribution, we can do the same thing. Any type of normal distribution we're working with, we can convert it into standard normal distribution by applying a new formula. In this new formula, we have x minus mu, same as the top. On bottom, we have only the population standard deviation, but this time, since you are sampling distribution, so we have to divide by our sample size, square root of the sample size. The sigma divided by square root. And if you put this in the calculator, you actually have to must put parentheses around here. Otherwise, you get a wrong information. Try putting something like this: 2 divided by 4 divided by 3 in the calculator versus 2 divided by 4 divided by 3. See, we get the same result. It's something interesting. 2 divided by 4 divided by 3 gives us, oh, I didn't see, 0.17. What difference it makes if you put a parenthesis? 2 divided by 4 divided by 3. 1.5. So it's a huge difference. So in order to use this in a calculator, you must put parentheses around the denominator. Otherwise, the answer is wrong. So from my experience, during exam, most of the students don't put parentheses. They get completely different results than what they're supposed to get. So make sure don't make this mistake. Any question? No. Okay, let's see if I can get to one example. What do I have? Population, proportion. This is proportion, proportion, proportion. Okay. So in our next class, we are going to do proportion. Today we are working with mean. Something like this one. A random sample of size 64 is selected from a population which has a mean 80 standard deviation 10. What are the mean and standard deviation of the sampling distribution of the sample bar? Sampling distribution of sample mean. X bar means sample mean, okay? I was too lazy to write down the whole thing. So what is the mean of the sampling distribution of the sample mean and what the standard deviation of the sampling distribution of the sample mean? Sampling distribution of the sample mean. It's a big word. So in other words, what is mu of X bar? And what is standard deviation of X bar? What is the mean of the sampling distribution? The mean of the sampling distribution is same as, what did I tell you before? Population mean, remember? The mean of the sampling distribution is same as the population mean. Do we have population mean given to us? How much is it? 80. So we don't need any math. We don't have to do any work at all. The mean of the sampling distribution is same as the mean for the population. And they already told us it's 80. But for standard deviation, we have to do some work, right? What is the standard deviation of the sampling distribution? Sample size. So do we know what is the population standard deviation? And do we know what is our sample size? A random sample of size 64 is selected. What is our sample size? 64, which is 10/8, whatever that is. So that's how we are going to work with this type of information. 1.25. Thank you. 1.25. Yeah, we can start here. We can do B and C. Yeah. In our next class, and most likely we are going to finish separating it in our next class. So remember, Wednesday we are online. Next Monday no class. Next Wednesday online, and then in academic next Monday. And don't forget to do all the homework. We are done in chapter 7. So make sure you complete chapter 7 homework, chapter 6 homework, and start chapter 8 homework.